Hi, Thomas Willingham here with Christopher Chapman. Welcome back to Networking Fundamentals. We're in Module 1, Understanding Local Area Networking. Christopher?
Well, that's pretty much what we're here to do. We're going to dive into our content finally for everybody who's excited and waiting anxiously to learn more about networking, which I know everybody is, because that's all everybody wants to learn about.
Who couldn't be? Networking.
It's true.
I mean, what more could you ask for?
Although it is kind of the foundation to everything I've ever done since I learned it. So I'd say it's important for that reason.
Agreed.
Yeah, we're going to jump right into some content and start giving you guys some information. It's going to be a lot of, I'd mentioned in the intro, a lot of kind of topic or word definition. It's a lot of just technical content for the next little while. We're going to throw in some demos, hopefully to keep a little bit exciting, show you a little bit about what we're talking about, and get through it as best we can.
Module 1 is basically kind of an overview type module, so people may see it as a little drier, but I think with some of the slides that Christopher's created, we've got some really good animations going. So I think we're going to see some good high-value edutainment here, where you not only get some education, you're going to get some entertainment.
We certainly hope so.
Okay, so let's dive in. Okay, so understanding local area networking. First of all, we have objectives. And when we teach this course, we want to be talking about or keeping in mind that there is a test associated with this course. Christopher, how does that test work?
Well, that's an interesting question. The tests, from a technical standpoint, they're multiple choice. What you're seeing here on the screen is we break our test down into objective domains. We want to kind of create a map of what the test is going to cover. And then we then use that map to create courses similar to this one, or our instructor-led training, that map to those domains so that we make sure we're covering what you would need to know for that course or that exam when you go to actually take it. These exams, I've taken, I think, 3 of the 4 kind of intro IT MTAs. I took them when I came on at Microsoft just so I had the information and was familiar with the tests. They're quick. They're not too bad. They're about 35 questions. I think you're given an hour, a little over an hour to get them done. So that's the long and short of the test. It's a lot of multiple choice, and hopefully we're going to give you the information to pass them.
Okay, sounds great. Let's go ahead and dive in then. So our objectives for the first lesson here, the first module, are we're going to be talking about examining local area networks, devices, and data transfers. We're also going to talk about identifying network topologies and standards. So network components and terminology. Let's see what we have here. We have data. Basically, this is a unit of information that's going to flow across a network. We have nodes. These are end devices that are on the network. Client. You basically have a client and a server. The hard and fast of it is a client requests services, a server fulfills services.
That's pretty much it.
Peer. Peer can perform either action. It can be a client or a server. And you'll find in a lot of these systems that a lot of these devices act as peers. Network adapter. To gain access to the network and gain access to other devices, you need a network adapter of some kind to allow you to access the media. Hub. This is a device that multiple devices hook into that basically spreads the data around to other devices so everybody has access to it.
And that's one of the first things we'll be covering in the slides coming up.
Switch. Switch is similar to a hub. It has a little bit different functionality. There's also router, and these are basically network utilities or network devices used to connect multiple devices together. Media, this is what devices talk on. Media could be cable, wireless. There's different types of media. Transport protocol. Transport protocol is what's used. So basically, any system that enables communication has rules. Let's think of the English language. It has rules. Christopher, you and I may have grown up in different parts of the country, but we're still able to communicate with each other because the English language has a basic set of rules. For networking, those are referred to as protocols or standards. And by using these protocols or standards, different devices are able to connect together and intercommunicate.
And in some cases, different systems entirely, different vendors. Microsoft has an email server. 100 other companies out there have email servers, online email services. They can all still talk to each other.
Exactly. And then finally, bandwidth. This is what you can actually use to transfer data across a network. What's available to you? Local area network. So basically the basic definition of what a local area network is. A local area network is a group of computers confined to a small geographic area, such as a single building. So this is the basic building block of what a network is.
Yep. In some cases in my past, that would mean my dining room. There have been times where, when I started learning, I don't know how many other people in IT do this. I've heard some stories from some other people. You want to get used to networking. You want to get used to building networks. You want to get used to servers and the services they provide, which we're going to talk about later. So I've had times in my life where a dining room is full of 6, 7, 8 computers just stacked up in a corner somewhere. Nice and out of the way and quiet and not bugging anyone else in the house, of course, taking up any space at all. And that's essentially a LAN. It's a small geographic area, small room, computers connected to it.
Okay, another kind of small example like that, it's game night. It's game night. You, 4 or 5 of your friends have all brought your computers over, have all brought their monitors over. And so if they all interconnect and use a hub, is that considered a network?
That is a LAN. That is a LAN, exactly.
Oh, perfect. Great. Okay. So basically a group of devices that share a common medium, such as cabled or wireless.
And that one's, we'll get into some finer points. That one's a little tricky because technically a LAN can, in this particular instance, given that definition, a LAN can have both and still be considered a local area network. I can have a wireless device plugged in via a wire to a hub or a switch, which we're going to learn about. And that provides wireless access to computers that also have access to wired computers via that other device. So, yeah, same idea.
So typically when we refer to local area network, we're referring to a smaller geography, so devices that are closer together as opposed to, I'll just throw out a term, a wide area network where things are more geographically dispersed, maybe buildings, countries.
Yep. I'd say here, even in the building we're in right now, it's four floors. I'm not even sure we'd consider the building a local area network. It might be per floor a local area network. A lot of that would come down to how IT has it set up and how they've divided everything, but I don't have access to that private information. So.
Well, and local area networks also deal with like sub-networking and things of that nature, which are some exciting topics that we'll be dealing with here later.
Indeed.
There's a hook right there. If you're thinking of, hey, I don't know if I should watch all of this, we're going to talk about sub-networking later. So if that doesn't hook you, I don't know what will. So let's go ahead and talk about the basic of a network. So networks are used to exchange data, and reasons for networks include sharing information, communicating, organizing data. So this is all kind of generic. Sharing information. What kind of information could we share, Christopher?
Anything. Pictures, music, movies. On a LAN that we have licenses for, of course, we don't want to get into the gray area here. But really any information, documents. At work, where we're in a work environment, we share information all the time. We have shares where documents are stored. We have, not to get too far out of the idea of a LAN, but we have other services that provide sharing to other information elsewhere on the network as well.
Well, and you and I shared information when we were creating this presentation. So as we were creating this presentation, basically what we did is we had a central area on the network that we would connect to. Christopher would work on the slides, I would work on the slides. So we would use this area to share information and organize information.
And for the sake of a little cross-promotion, one of the nice new things about some Microsoft software, we were able to share that information and not have to copy it locally because, Office lets us do co-authoring. So nice little plug for another product group.
Yeah, and it was relatively seamless what we were doing. So as Christopher would work on the deck, I would receive a note that, hey, Christopher's working on the deck. I would save, it would bring his changes down. I could edit, save, it would push my changes up. Worked really nice.
Yep.
And then communication, basically email. So we use these tools on a day-to-day basis. Email, we stream video, we use tools, SkyDrive, Dropbox, tools of that nature, and we don't even think networking. And that's really the beauty of networking, is it should be seamless. It should just be something that we use, and a good network is seamless in that nature, where you just use it and there's not a problem with it.
That's true. That's true. And hopefully people watching this video haven't had too many experiences to the contrary, although it is possible.
Every once in a while, I've heard they go down.
It turns out, although as soon as you say that in my head, I hear the thousands of times that I've heard people say, the network's down, the network's down, the network's down. The network probably isn't down most of the time, but there are things that can cause some issues from time to time.
We might even talk about that later. Again, another hook. If that's not going to hook you, again, I don't know what will.
Maybe we'll cause some. Maybe we'll break some stuff while we're here today.
We can break stuff?
Yeah, we can.
I might have a hammer.
That would be an interesting way to break a network.
Network documentation. So network documentation basically helps describe, define, and explain physical and logical methods for connecting devices. Documentation phase. So as you're creating a network, there's different phases to it, a planning phase, a pilot phase. Actually, documentation phase is one of those. And that's where you basically sketch out what you think the network's going to look like. And then if you're thinking about tools, Microsoft Visio is an example of a tool that will do this. There are some tools that will even load up and go self-discover devices on your network, kind of pull it down into a Visio-style diagram, and then you can kind of note and arrange stuff as you'd like. Hub. Okay, as we were going through our terminology, we mentioned hub, and Christopher mentioned that we'd be talking about this later. So, Christopher, why don't you talk about hubs?
Well, hubs, to be pretty simple, are really the simplest connecting device a network can have. We're assuming that we're not doing peer-to-peer connections. Most people don't do that. Hubs were one of the first devices used to connect computers together. They're very simple. It's a box you plug into. We're going to talk about cabling and network cards. You plug your computer into this box. It listens for activity going on the network. It hears something from a port where you've plugged in one computer. It then takes that information and sends it out to all the rest of the ports in the box. It's assuming that this computer is trying to talk to somebody. I'm going to take that information and send it out to everybody and see who's listening.
Okay, so let's go ahead and take a look at the animation here that kind of demonstrates the functionality of a hub. So basically we have our devices here and we have our hub, and those lightning bolts represent data traveling or that could travel across the network. And basically what we have is we have this little dot here representing a packet. So this is a server or a device requesting information or sending information to another device.
Yep.
So notice what we have here. That unit of information goes to the hub. Now the hub doesn't pick what device it sends it to. It just broadcasts that information to all the other devices on the network.
Yep. And if any of those devices don't need that information, they just ignore it. They still get it. They still hear it. They just pay no attention to it.
Okay, so if I'm in a room talking to a group of people, but I'm talking specifically to Christopher, I'll use his name. I'll say, hey, Christopher. The other people in the room, although I'm loud, will hear my voice. They'll know that I'm talking directly to Christopher.
Pretty much. It's a good analogy.
Okay, so we have a hub. Now, a switch, on the other hand, is kind of a fancy hub. It's a smarter version of a hub, where a hub takes in information and then broadcasts that everywhere. A switch, on the other hand, is more selective about how it sends out information. How is it selective, Christopher?
So another thing that we'll talk about a little bit later is what's called a MAC address. It's an address assigned to the physical network port on a network card in a computer, on any computer. Every computer that has a network card, that network port has an address assigned to it. And we'll get into, there are actually multiple types of addresses assigned. What a switch does is it keeps track of which addresses from which devices are connected to it. So it's not that the ports on the switch have that address themselves, it's just that they know who's at the end of it. So when computer A sends me a piece of information, the switch is going to look at that information, kind of open it up a little bit, look at the header, the top of the file, and say, this is destined for a computer that has this MAC address, is what it's called. And we'll learn about that more. I know exactly which port that MAC address is connected to, so I'm just going to send it down that port.
So basically what we have is instead of that information being broadcast everywhere, it's broadcast to specific ports. So now our network's not flooded with basically all this noise or all this data being transferred everywhere. The information is basically sent along very specific paths. So let's take a look at the PowerPoint here. And Christopher, again, has another amazing animation that will demonstrate how this works. So notice, again, we have the start system here that initiates a packet being sent. It sends the packet to the switch. This is where Christopher mentioned, hey, the switch evaluates where is the destination and says, hey, the destination is this system. And at the same time, another system initiated a packet, sent that to the switch, and the switch said, hey, that goes to this one here. So it really allows, so a hub basically takes anything and broadcasts it out. A switch, on the other hand, is very deliberate about receiving a packet and then sending that packet on a very specific path.
And one of the things that brings us in terms of bandwidth, we talked about bandwidth on the first slide. You see when you purchase these devices, they're rated for a certain amount of bandwidth. You'll see hubs with 10 megabits per second, 100 megabits per second. You'll see switches with 10 or 100 or even 1,000 megabits per second if they're a gigabit switch. One of the very important differences that even I didn't learn right away when I started learning is that with a hub, because of the broadcast nature of the technology, that bandwidth advertised on the device is shared. So that hub can support 100 megabits per second across all of its ports at any given time. So if I'm sending a large file to a server or to another computer in my house, and someone else decides to send a large file to another computer, my bandwidth gets essentially cut in half so that they can have some to use as well. Switches, because they have addressable ports and can keep track of where traffic is supposed to go, that is not the case. Switches, that traffic is available to every port at any given time. Now, if you have two computers, say, sending a large file to the same computer, you're still going to run into bandwidth issues because now you've got the same two ports bringing in traffic, but only one sending it out. But the switch as a product is technically able to support all of that bandwidth per port.
Okay, so next we've talked about the hub, we've talked about the switch. Now let's talk about a router. So if we look at the slide, basically you see that the configurations look very similar. The hub, the switch, the router. There's what we refer to as a star topology here. So all these devices star into the router. The router enables computers to communicate to a different network. Mm-hmm. We haven't quite talked about that yet. The easiest thing to think about is, and the way most people think about routers is, a router enables me to communicate with the internet.
Yep.
So I have my home network, my work network. It has one LAN, one type of network on it. I use my router, and it enables me to connect to another network, at this point being the internet.
It's the best example that we can come up with pretty much any time.
Okay, so if we look at the graphic here, we see that the internet, that big huge cloud, and Christopher's using some very basic graphics here. So when you see a cloud like this, they're typically referring to the internet. When you see a device in the middle like this, that's typically referring to a hub, a switch, a router. The kind of block on the left, typically a server. The one on the right with the monitor and the block, the computer, is a computer, and then the basic one on the bottom is a laptop. So we talk about documenting your network. This is the type of icons that you'll use to document your network.
Potentially, yeah.
So we've talked about hubs, we've talked about switches, we've talked about routers. Now let's talk about how we get devices connected to a hub, a device, a router. So basically, how do we get connected to the network?
Sounds about right.
Okay. So we have a network adapter. I'm sure pretty much if anyone has looked at their computer, laptop, desktop, whatever, they've probably seen this type of port. For those of you that are a little bit older and are familiar with hard LAN telephones, I'm dating myself here. I just talked about a hard LAN telephone, a hardwired telephone. This looks like a hardwired telephone jack.
I just think it's funny that we're talking about it in that context. For the older folk out there, you'll remember back when we had telephones.
I know. Remember when we had wires?
When we had to plug a phone into the wall
Exactly.
with the cable.
And you had to dial the phone. So basically what we have here is this is an RJ45 jack oriented piece of hardware. RJ45 jack is just a little bit wider than a telephone. So that is the connection area for the computer, for the wire. And then what you see on the other slide here is the RJ45 jack that you use to connect to the computer. This is for what we would refer to as a wired network.
Absolutely.
As opposed to wireless. Most people at this point are probably more familiar with wireless than they are with wired. But if you're going into networking and want to understand, these are still terms that you need to know and need to understand.
Well, and if you're looking to go into networking from a business standpoint, if you're looking to maybe start an IT career, advance an IT career, these are terms you're going to want to know because a lot of corporate networks aren't wireless. They provide wireless. Here at Microsoft, we have wireless networks that I can connect a laptop to any time. But if I sit down in my office at my desktop, or even with my laptop, I have a wire that I can plug into. And if you're responsible for managing, setting up, designing a network, wired is going to be a large part of what you're doing.
Well, and even though your network has wireless in it, most likely when we talk about servers are going to be wired.
Yeah, absolutely.
So there's going to be part of your network infrastructure that does have wires associated with it.
Yeah. I can actually tell, I was looking at the pictures and I'm remembering funny stories. Back when I was learning how to do all of this, how to build a network. I was 14, 15 years old. I had gotten a copy of NT4 perfectly legitimately from a reputable source. And I just wanted to learn, and I tend to learn by doing. So I put NT4 workstation on a computer in my bedroom. I put NT4 server on a computer downstairs. This is my parents' house. I went to some store, I can't remember what the store was or if it even exists anymore, and I bought a kit. And this kit came with a little 10100 hub and two 10100 network cards. And I had to install the network cards in both of these computers, and I had to put the hub on the stairs, like on the 4th or 5th step of my parents' house, and then run cables up and down the stairs to my bedroom and to the family room, which my parents loved. They were thrilled. The part of the reason I tell that story is because I still have those devices at my house. I still have the hub and at least one of the network cards. And one of these will actually frame them because it was my first networking experience ever. Was going to the store, buying this stuff, and just setting it up at my parents' house and figuring out how it works.
And for those of us that are kind of geeky and bent like that, that's what we remember. Like some people are like, oh, my first kiss, my first car. Hey, and not that your first kiss and your first car aren't awesome, but your first network card and the first time you get devices to intercommunicate, nothing better.
It's a big
just
deal.
Saying.
What are these IP addresses all about? We'll have plenty of stories for that when we get to it.
Okay, so we've talked about wired networks and how wired networks intercommunicate. We've also kind of hinted about wireless, so the ability to connect a device without wires, and that's what people are most familiar with, whether it be a phone, a tablet, a laptop. You go into Starbucks, you go into wherever, you prop open your laptop and you start working and immediately have internet connectivity because of wireless.
Yeah.
So the basic wireless device is a wireless access point. And a wireless access point is what's used on a network to allow wireless devices to connect to the hardwired network. We've talked about wired networks, and that's going to be the backbone of any network, is going to be wired. And then you will have areas that allow wireless to connect to your wired network. Wireless access points are basically what do that.
Yep.
And they allow smartphones, PDAs, tablets, laptops, PCs nowadays.
Even desktops, yeah. Desktops will come with wireless adapters, so you can take it home, unbox it, set it up. You don't have to worry about it. It's just one less wire to junk up your office, bedroom, living room, wherever you put your computer.
Well, and some of us enjoy having the hub in the living room and a wire running to every bedroom.
By some of us, it's like 3 of us, but we do. We love it.
It's neat, you know, and tripping over it in the middle of the night just reinforces that joy of, I have a network at home, I rock.
Oh my goodness.
But, you know, for those of us with families and stuff, with spouses who are like, yeah, you're not going to run wires all over the house. Thank God there's wireless. There's wireless. We can put wireless in. I can go to my bedroom, the kids' bedroom, whatever, and still have access to the network. It's demo time. We kind of drew straws and we decided that Christopher was going to be demo Dolly this time. So we're going to head over to Christopher's computer. And what do you have for us, Christopher?
All right, well, I think we're going to look at we're going to look at the devices we've talked about from a computer standpoint. We're going to start with Device Manager. Actually, I'm going to start somewhere else. So on a modern PC, we're looking at a Windows 8 PC right here. I've cleaned up the desktop. I've just put some shortcuts here that we're going to be using, but I don't want to start there. If you're a home user, if you're an office user who, again, is getting into networking, getting into IT, what you're going to be able to get to quickly and easily is right here. This little icon. And this little icon takes you to Network and Sharing Center. And I'm going to jump right into adapter settings. These are network cards. Now, two of these, the ones on the right, we're not going to pay any attention to. Those are not what we're talking about from a LAN standpoint. This right here is a software representation of the network card in my computer and the properties associated to it. So we have protocols in here, we have different connection items. We're going to talk about all of this later. But for now, we're going to close this, and I'm going to show you a little bit different view of essentially the same information. So back to our desktop, and I'm going to actually open Control Panel. And once we're in Control Panel, a couple of different ways we can get to this information. One of the joys of Microsoft, they like to give us 5 ways to do everything, which is terrific. You get to pick the one that works best for you. We're going to open up Device Manager, and we're going to take a look at network devices from a Device Manager standpoint, right here under Network Adapters. And again, we see the same adapter as we saw before. This one, when you come into properties, it's a little bit different. These are actual hardware properties and hardware settings that we're looking at and can change. There are many, many settings on a network adapter, on a network card that can be changed. We're not going to get into these details. You don't need these details for the sake of this exam. So you can take a look at this. You can play with these if you want to, if you have a network where it's not crucial that you're connected to it, because changing some of these may at least intermittently disconnect you from that network. And our last bit is an actual IP address. I'm going to look at this from, unfortunately, the way this computer's set up, I can't go into those property sheets to look at an IP address. I can do this. And I can do IP config, which is a tool we're going to learn more about later in much detail. And this gives me an IP address. 10.0.0.39 in this case is the IP address on this computer. Above that, you'll see an IPv6 address. We're going to talk about IPv6. We're actually going to talk about everything you're seeing, IP addresses, the IP protocol, the internet protocol, the different versions. All of this will be discussed in more detail later on in this content. I'm going to close that. We're going to hand this back off to Thomas.
Okay, great. Thanks for the demo, Christopher.
No problem.
We, and when I say we, I'm talking about myself and the audience, appreciate your hard work.
Well, thanks.
You're welcome. Okay, so next up, serial data transfer. So how is information basically transferred, or a method of transferring data across the wire? One way is serial data transfer. And what this refers to is the transfer of information 1 bit at a time. Very similar to like a single lane highway. So as cars get on the single lane highway 1 at a time and go to their different destinations. On a network cable, the data travels in one specific direction in a single stream. So serial data transfer, there's also data transfer rates. So how fast can data be transferred across these different media? They define maximum bits per second, BPS, that can be transmitted over a network. Typically rated in bits, using a lowercase b, for example, 10 or 100 megabits per second. The lowercase b differentiates this from the uppercase b. Uppercase b, bytes, typically hard drive and RAM. Bits, network communication, lowercase b.
So to kind of bring a real world example to that, because this is something that people actually interact with and I'm not sure they realize it most of the time. When you go to your cable provider, your DSL provider, whoever's providing internet, say at your house or at your office, and you run speed tests. My internet's running slow. I need to go look at why it's running so slow. They're going to do data transfers to test that throughput. Those data transfers are going to be represented most of the time in bytes. So when I go to my provider and I run a speed test, it's going to show me a little meter with a little needle. That needle is going to show me bytes, megabytes per second. To get megabits per second, to get the actual speed of that internet connection as advertised by that provider, because a byte is 8 bits, you have to divide or multiply that byte number by 8 to get your megabits per second. So if my speed test shows 2 megabytes per second download, and I say, well, I bought a 16 meg line from my provider, so why is it only 2? If you multiply that to megabytes per second that the screen is showing me by bits, by 8, I get 16 megabits per second, and my internet connection is running the way it should.
Nice. See, you learn something every day.
You do.
Okay, our types of transfers, there's broadcast and unicast. Broadcast is basically information being sent to all devices. Unicast is information being sent to a specific device. So broadcast, the way to think of broadcast, an example, radio. So somebody talking over a radio, that gets sent to multiple devices. Unicast, walkie-talkie. So when you're on a walkie-talkie, those are only going in between those two devices. IP addresses. So we've talked about devices on the network. We've talked about broadcast. We've talked about unicast. How does a device know, or how do devices know a specific device that is being sent information? They use an IP address. An IP address is similar to, here in the States, we use social security numbers to uniquely identify each person. Networks use IP addresses. Christopher talked about MAC addresses, media access control addresses. Those are the hardware addresses that are physically associated to the computer. IP addresses are addresses associated by the TCP/IP protocol associated to the MAC address. Again, this lets devices know who two devices are talking to. So when they say, hey, I'm talking to 192.128.1.1, they know, hey, 128 or 192.128.1.1 is this specific device, and it allows device intercommunication. Most devices connected to a network have an IP address, and devices that we might not even think about. Again, we go back to that list of wireless devices, a phone, a tablet, a PC, a laptop. These could all be a router, a switch. These could all be devices that have an IP address.
Potentially, yeah.
Again, they uniquely identify devices on the network. They give an example here, 192.168.1.1. And every IP address is broken down actually into two components, a network component and a host component. The network ID basically shows what network the system is on, and then the host ID says, hey, this specific device.
And by what network the device is on, what do you mean by that?
So you've talked about bandwidth, and we talked about local area networks. A local area network is, and one we've said it's a geographic area. So it's a geographic area that shares the same network ID. The same network ID, all devices on a network share the same network ID. And in our example here, the 192.168.1.1, the network ID is 192.168.1. So all devices that share this first three numbers are all on the same network. The .1 uniquely identifies a device. Now we talked about a hub, a switch, and a router. All devices on 192.168.1 are all able to communicate using a hub or a switch. To communicate with a device on a different network, using this example 192.168.2, we would need a router device. This allows us to basically create areas where we have bandwidth. So we're going to have these devices using this set of bandwidth in this network. Then we're going to have another network over here of a different group of devices that again share bandwidth. Then we can use a router to interconnect these two different networks. So if we look at a local area network, as Christopher had just mentioned, you'll see here, again, using our documentation kind of standards, some different items here. You see some servers, you see some routers and switches, you see the internet. The brick wall is typically what's used for a firewall.
Yep, and I put that in here with a note to myself that a firewall, especially in this representation, is essentially a router with additional functionality. Firewalls are going to allow you to interconnect two networks, but with a large amount, depending on the firewall you're using, of security ability that a typical router may or may not have.
So it sounds like your firewall is basically your gatekeeper that allows your devices from your network to communicate to the internet, but the internet, all of the internet, not to be able to communicate directly to your devices.
Yeah, we
inside.
don't want that necessarily.
And that's how we create like denial of service attacks and things like that, is firewalls not being properly set up and allowing what you could refer to as malicious communication to come in from the internet into your internal network.
Yep. Or sometimes externally. I don't know if we'll get into those details today, but sometimes firewalls can be used for containment. If something has managed to get to my network, has a virus, malware, some sort of other potential security issue that could happen inside a network, that firewall may keep it contained. If I have other sites that I don't want it to get out to, there's a lot of, we get into security, we'll be here for weeks and weeks and weeks.
Very good, very good. And then notice, let's actually go back to the graphic really quick. Notice we also have a wireless access point here. So we have our wired network, we have our firewall, we have internet connectivity, we have devices connecting to hubs, we have servers. We also have a wireless access point and wireless devices connecting to the network.
Yeah, this is pretty representative of really any network. This could be at your house, although maybe on a smaller scale. This could be your office on any scale. This could be here at Microsoft on a massive and global scale. But at the end of the day, these are the pieces that make it up. Devices, servers, switches, firewalls, wireless access points. It gets much more complicated when you get into the details, but this is the general idea.
So at this point, people have a pretty decent understanding. Now it's just about scale.
Yeah.
So all these components, and these components, we've simplified stuff, and things in a basically production environment might be a lot more complex, but these basic hub, router, switches, client, server, peer, wireless access point, these are all things that you'll find in your neighborhood,
Yep.
basically.
And in some cases in my living room, or in someone's living room.
Yeah, exactly.
Yeah.
Virtual LAN. So a VLAN is a group of hosts with a common set of requirements that communicate as if they were connected together in a normal fashion on one switch, regardless of their physical location. Okay, so let's take a look at what that means. We've talked about the fact that a switch has the ability to know the device at the end of the port. So hey, this is device 1, this is device 2. So a virtual LAN allows us to group those devices together. So hey, devices on ports 1, 5, and 10 are on a single network or virtual LAN.
And what that allows me to do is it lets me take a switch, which is not necessarily the smartest of network devices. It's not built for subdivision, and it lets me subdivide. It lets me say ports 1, 5, and 10 are isolated. I want those three computers to talk to themselves. I don't want them to talk to anything else or anything else to talk to them. So in this case, we've got computers connected to 3 servers, 3 workstations, and a wireless access point connected to 6 of the 10 ports on this hypothetical switch. And we've divided it according to the table on the left. This is called tagging. You're going to go into that switch. You're going to pull up the configuration for those ports. You're going to VLAN tag those ports with an ID. In this case, the IDs I've listed on the left, 1 and 2. We've basically divided this into 2 different networks. So ports 1 and 2, if we go from the upper left to the lower right, the way we normally read, the first two computers, the first server, and the third server are all on the same VLAN and the wireless access point. So those two PCs are wireless devices, and two of the three servers are talking to each other, connected to each other, fully functional as a network. However, port 3, which is our third PC, and port 7, which is our second server, are isolated. They're still connected to each other. They can still talk to each other. They cannot necessarily talk to the other devices on that switch.
And so an example of this might be your accounting department. Maybe you don't want your accounting department, the information there. Maybe they're working on super secret projects, or you just don't want accounting information on the rest of the network. You can separate the accounting area out. And so none of the servers, even though they're all on the same physical network, logically, they can't talk to each other.
Correct. And I could use a router to do that. I mean, I could use a router to physically separate those networks, but they're expensive. Part of the reason VLANs kind of came to be, it's a slightly less, well, in some cases, a considerably less expensive way to do this isolation.
So basically, we're using software implementation instead of a hardware implementation for this virtual networking.
Yep, in this case.
Okay, network topologies. Network topologies basically is how the network is physically laid out. There are different types of network topologies: bus, ring, star, mesh, and tree. If we look at our graphic here, the bus, ring, and star, mesh, and tree refer to a physical layout. So bus, basically inline. This is old style coax Ethernet. Basically what you would have is a single coax cable that would run from one area to another. As you hook devices in, you had a little T connector. You would start the cable, you'd hook it into one area of the T, so you have basically this T connector, the cable comes in one area, this connects to the device, this cable runs out this area, and then this device is now in line with the rest. The end device, you would have to basically put an end cap on to finish it up. And if any of the devices got disconnected or the signal didn't go quite right, your whole network went down.
Yep.
The best way to think about that, Christmas tree lights. Who hasn't fought over Christmas tree lights? The one bulb goes dead, all your bulbs go dead, and now you're sitting there, you know, drinking your sorrows away. Not that I advocate drinking, but drinking your sorrows away because you got to sit there with, what, a bazillion bulbs, and then try and pick one out, put the new one in. And so basically that's an example of that topology.
Yep.
All that Christmas light drinking thing, all for that example.
Exactly. Not much that you're going to see, luckily, for the sake of Thomas's not advocating drinking, luckily not a topology you see much anymore.
Ring. Ring is basically things connected in a ring fashion. And typically when we refer to ring, that's more a logical topology than a physical topology.
Yeah, the funny thing, we have a slide here in a minute that talks more about rings and mentions that the ring topology, even though it is a circle, actually is a number of devices connected to a central device. So it's one of the fun things I've had teaching over the years when I'm in different classes talking about networking, is that we show these graphics that are very simple representations of a bus, a ring, and a star. And then I say, well, technically a ring is going to look like a star.
But it works logically as a ring.
As a ring, yes.
Okay? Which brings us to star. And we've seen evidence of this before. If you think of that middle piece, that purple piece, that's the hub.
Or the switch, yep.
Or the switch. And then all the green is the cable. The purple is all the devices. And basically all that interconnection. Mesh is Ted Nugent double live free for all.
Yeah.
Mesh is basically everything connected to everything else.
Mesh is what you would have to do if you wanted a star without the central device. So I want to connect my computer to the three other computers on my network. I don't have one box that I can plug one cable into, that the cables from those are plugged into as well. I have to physically, and I've never actually seen, I don't know if this is good or bad, I've never seen a mesh implementation at this level, at a network level.
I haven't either. Mesh, they tout that it's for fault tolerance, but nowadays, and I think that was kind of in the day when hubs and switches tended to fault a lot more. And I think now with hardware being the way it is, switches, hubs, routers being as decent as they are, we've kind of gone away from mesh.
Well, you will still see mesh in some instances. The biggest thing I can think of right off the top of my head where you'll see a mesh topology is in fiber channel. If you're doing centralized shared storage, what's called a SAN, which we won't cover in this class, the connectivity to SANs in the back end in a server room, they tend to create a mesh topology. You're going to have multiple switches connected to a SAN. Those switches are going to connect to multiple servers, and in most cases, those servers will connect to both switches. The switches will both connect to the server or the SAN in the back end. It is a fault tolerance. It's exactly what it's for. It's to make sure that there's always a path between the storage and the server. So that's the best example I've seen mesh topologies in the world still today. You usually won't see it at the host level.
Well, and they tend to use mesh at also a router level. So all your routers tend to be more interconnected than not.
Yep.
One thing that they'll refer to that's not on the slide is hybrids. And that's pretty typical. So you'll have an area of mesh, an area of ring, an area of star, and all of these kind of collapse together.
Yeah, potentially.
And then finally, tree. I think Christopher was thinking about hiking when he wrote the slide, so I'm going to throw tree to Christopher.
Sure, throw a tree to me.
Yeah.
I'm trying to think of a good analogy for tree. I mean, it's not very common. We just kind of put it on here because it's information for people to have. It just kind of exists. It's almost like bus. I should move bus down to the bottom of this list only because it's not around anymore.
Okay.
So not something you'll need to know.
Okay, fair enough. So we've talked about network topologies. Let's dive into star topology a little bit more. Again, we've seen examples of this numerous times. It's the most common topology. Basically, this is your switch, hub, router device, and then all your network devices are connected to it, per the example here. The next one, mesh. Again, we've talked about this. Not real world for computers. It's more like you said for SAN storage or routers but basically you see here that all systems are interconnected to every other system.
A little expensive, that one.
Well, and things that people don't think about is you need a network card and network port for each of these cables. So for everything that's incoming, you're going to need network cards, you're going to need cabling. So as Christopher said, this can be kind of expensive. So ring topology. As we mentioned earlier, although it logically functions as a ring, it physically works as a star. Token ring uses this. Fiber distributed data interface, FDDI, uses this. But like I said, typically the physical layout is a star layout.
Device is plugged into a central connecting point.
Typically token ring uses a star topology, and actually next slide.
Very fitting, yeah.
Next slide. So token ring, the idea for token ring is you have the talking stick. If you don't have the talking stick, you don't get to talk. And in this case, the talking stick is a token that's passed around in an orderly fashion. And when a device receives the token, the you can talk token, if it needs to talk, then it puts information on the network. If it doesn't need to talk, it says, hey, I don't need to talk, and basically passes the token to the next designated device.
And then the data passes the same way. So if I get the talking stick and I'm allowed to talk and I need to talk to computer 4 and I'm computer 1, I'm going to send data. That data is going to, very similar to what we talked about earlier with the hub, it's going to visit each device, and those devices are going to say, you're not for me. This is my data. Pass it on to the next one. Not the most efficient.
And then finally, Ethernet. Ethernet is a physical topology. It's from the Institute of Electrical and Electronics Engineers, IEEE, and it's standard 802.3. So we talked about standards, the English language, protocols. This is the protocol or the standard that allows devices to physically connect to a network. It mentions that Ethernet is the de facto standard. There's multiple types of standards here. There's ones that have been voted in that a whole bunch of groups agree on and say, hey, we're going to make this the standard. There's also the de facto standard. So this is the standard that we've used forever, so we're just going to agree that this is what we're going to use.
Yep.
Some examples of some Ethernet include 802.3U, or fast Ethernet that runs at 100 megabits per second, or 802.3AB, or gigabit Ethernet.
Which is 1,000 megabits per second.
So we have Ethernet, which is a representation of the physical media and how information is put on that physical media. Well, information is put on the physical media in frames. Basically, the way to think of a frame, you could think of it like a postcard. A postcard has areas that you write in. It has an area that you write information to, Dear Aunt Joan, I'm having a great time. Glad you're not here. Okay, no, I really miss you. So it has the body of data. It also has the address information and the from information. So that's a really simple way to think of a frame. A frame's going to have very similar type of information.
Yep. And the slide covers some of that. We've got this broken down into pieces. I didn't define all of the pieces of a frame. These are actually representative of the areas of a frame, but I didn't label them all because it's not, that level of detail is not required. But in this case, our preamble, it's going to be that to and from, where's this going, where's it coming from, the data, which is the bulk of obviously what we're sending, and then at the end, CRC is a checking to make sure that the frame is complete when it gets received.
So basically, a CRC allows, when Aunt Joan receives her card, she can look at the CRC and ensure that nobody wrote other information on that card.
Well, in this case, it's the same idea, yeah, just to make sure that the card's complete. In this case, you're going to look at the postcard and see that it's got all four corners and all the stuff's written on it. There's no eraser marks, there's nothing torn off. That's kind of what CRC is. Now, we're actually going to mess with this definition pretty considerably later on as we go through the layers of the OSI model, which we're going to talk about. And frames are just one piece of between, if I'm sitting at a computer and I want to send a file to you, between me telling the computer to send that file to you and it getting to you, that file undergoes a number of changes. And frames are just one of the stages of change. But we'll talk about that more in detail later.
Right. As mentioned, the frame is layer 2 of the OSI model. Teaser, there's 7 layers of the OSI model, which, as you said, we'll talk about later. Centralized computing. There's a couple different types of computing. One is centralized. This is computing done at a centralized computing. So basically what this allows is a central device has all the computing power. It's not uncommon for the systems that are interconnected to it to be referred to as dummy terminals. This is more a mainframe environment. And in the mainframe environment, these dummy terminals boot up, and any processing done is done by the mainframe system. The dummy terminals typically have a keyboard and a monitor, and that's about it, at least in a mainframe environment. Like I said, they're referred to as dummy terminals, and these devices solely are keyboard and monitor.
Well, and I think to myself, in my head, my first thought is, the people watching this video, go ask your parents what a green screen is, and they might be able to tell you.
Oh, yeah, exactly.
Yeah,
exactly.
That's the first thing I get in my head when I talk about terminals. I talk about green screens back in the day. So, hurts me that I'm now the person saying, "Kids, go ask your parents."
Go ask your parents about it. Oh, the old Weiss terminals.
Yep, exactly.
All the Weiss still has terminals. I'm not trying to say Weiss is no longer valid.
Well, and there's a saying, and it holds true in IT very, very well, which is what was old is new again. So 25, 30 years ago, there were these dumb terminals, these green screens connected to mainframes. Nowadays, we have terminals, still Weiss terminals, or there are various different vendors that create these, what are called thin clients. It's a box that doesn't really have an operating system on it that connects you to a server that gives you a full, in this case, Windows operating system. We're not getting into those details. Remote desktop services is the overarching, which you can speak to at some point in the next couple of modules, is the overarching technology, but we're not going to cover that in this course much.
Okay, fair enough. So after centralized computing, we have client-server model. In a client-server model, as I mentioned earlier, a client requests services, a server fulfills services. Server systems could be Windows Server 2008, Windows Server 2012. A client could be Windows 7. A server could also be Windows 7.
Could be technically.
Yes. Yeah, and we'll actually talk about that next in peer-to-peer networking. In peer-to-peer networking, we've talked about a client, a device that requests services, a server, a device that fulfills services. In a peer-to-peer network, a device can function as either or. It can request services from another device, or it can fulfill services from another device. File sharing is an example of a peer-to-peer system. And in some small offices, they may find that a peer-to-peer network works okay for them. They don't need a centralized server to run their systems.
Certain expenses related to that centralization. So if you've got 5 to 10 computers, it's a decision point, I guess you could say.
Exactly.
Yep.
After peer-to-peer networking, distributed computing. Distributed computing is basically a hybrid type of environment. It includes both client-server and peer-to-peer networks. Every device has its own processing power. So now we're getting away from, say, dummy terminals, and we're getting more into, as you mentioned, thin clients. So each device has the ability to process its own information, but it may still request information from other devices.
Yep. And in this case, distributed computing, when we say both client-server and peer-to-peer, we're at Microsoft. Microsoft is very much a client-server environment. We have servers, we have clients, but it doesn't stop me as a user from creating a folder, putting content in it, and sharing it out to the network for other users to access. I'm now making kind of a peer-to-peer connection on this very large client-server network.
Hey, look, remote desktop services and remote sessions.
Shocked that slide made it in here. Shocking.
I think I put this back in here. As we mentioned, as Christopher mentioned earlier, everything old is new again. Centralized computing's made a comeback of sorts. Remote desktop services and remote sessions to computers are based off the centralized computing model. So basically what we have here is in remote desktop services is the ability from one system to do what we refer to as presentation virtualization. So now, over the network, I'm just getting a screen. So all the processing power is done at a central location, and all I'm receiving are screen updates. Thomas, you may say, I don't understand the benefit of this. Well, in a large network, thousands of clients, maybe you're running an older version of your client OS, and you now want to update what client OS your systems are running on.
Time for 8.1 when it's available.
Exactly. So now what we might want to look at is instead of that hardware cost of updating all those clients to enable them to run the new OS, as a method, you may want to use remote desktop services. So now my older client can run a newer operating system, but the operating system isn't run locally. Another example of why I can do this all day.
Well, I was going to say the reverse might actually be true. We've decided to put all of we've decided to send all of our old computers out to pasture. It's time. They're 10 years old. We're running Windows XP. We don't want to run Windows XP anymore, which nobody should be running Windows XP anymore. But there are applications I have that have been written for XP that only run on XP. Well, we're going to get every computer out of the building and we're going to replace them with brand new shiny hardware and Windows 8.1. I can't run my applications on Windows 8.1. Someone on the network, some administrator can set up remote desktop services to allow me to remote in and run that application in an older environment, in XP and Windows 7, elsewhere.
And at that point, all your data is held at a central location.
Potentially.
Yeah. So as employer, what you could do is you could have your centralized server running remote desktop services. You could have people that remote desktop service in, use remote desktop connection, connect in. Now you have a bit of security added, because if they lose their data or not their data, but their laptop, their physical device, all their information is still stored in that central location.
Absolutely.
To get them up and running, all you need to do is get them a new device, they connect to the remote desktop, and boom, they're up and running again. Servers. So servers, again, the easy definition, they provide services. Well, what type of services do they provide?
What don't they provide? In this case, we've just put a couple of on here that are the most obvious examples. File services. 90% of the people out there, regardless of IT career or just user in an office or at home, are familiar with file sharing, with getting a file off of another computer, getting a file in some cases off a central computer. That's the easiest example. Print services in most offices, especially here, I don't have 100 printers connected to my computer at my desk, but I might want to print in color, I might want to print in black and white, I might want to print different sizes, I might want a plotter so I can print posters. I'm not going to plug all those devices into my computer, and there are 100,000 people who also might want to use those printers. I can plug all of those printers into a centralized server and provide those printers through services to the entire network. The rest of these, database, messaging, email, web, it's similar to some of our other lists we've had. These can go on for days and days and days.
So we have a list here of client and server operating systems. This list is by no means inclusive of everything. We've just listed some Microsoft ones here.
It's weird that this would only show Microsoft software on it.
How did that happen?
It's crazy.
Yeah, crazy. And as we said, remember there's client, there's server, there's peer, and some of these devices can or some of these operating systems can basically function as both.
Yeah.
Peer-to-peer or P2P has recently taken on additional meaning, because we're kind of used to, hey, devices in our office have interconnected. The secretary wants to share something with the manager. Using peer-to-peer, they share that file. Now there are specific file sharing networks. Napster, Nutella, G2.
Public file sharing networks.
Public, correct. Other technologies also that we may not even think about take advantage of P2P file sharing. Skype, voice over IP, or cloud computing.
We're not going to go anywhere near cloud computing. We could.
We could
spend another week on. We could spend a month on cloud computing.
There would be good stuff to be had. That's a great conversation.
Yeah, it is. In fact, we're going to hope to have more of those here in MBA. So, once you've learned networking, you decide to go from the beginning end to the finishing end in terms of knowledge and architecture, we're going to have lots and lots of cloud content eventually.
Well, and I believe that you can download these, so you can listen to them on your device as you ride the bus, or while somebody else is watching a TV show in your house that you don't care about.
Absolutely.
Or whatever. So, I mean, you could consume these.
I watch MBA sessions at the gym. I don't know if I'm supposed to say that. I'm kind of an Uber geek. Get me on a treadmill and I'll just listen to an MBA course on Server 2012, what's new coming up anytime.
It's just a good way to keep up on the different technologies. Technology, there's two things. It's a treadmill. It never stops. And it's a fire hose. Information comes at you at such a high rate of speed that, yeah. So think fire hose, think treadmill. But also, there's a lot of information to be had. As I've mentioned earlier, think hug, because we're going to give it to you in a really gentle, nice manner, and just make sure that you get the good stuff.
Hopefully you think it's gentle and nice. We'll see how that, we get evaled on all this, so you can let us know.
Okay. So now we're kind of at a summary about what we've talked about. So we've talked about understanding local area networks, LAN elements, design perimeter networks, IP addressing, and LAN types. We've talked about understanding network topologies and access methods. Topologies, star, ring, mesh. We've addressed Ethernet architecture, client-server, peer-to-peer networking models. We've actually covered quite a bit of content.
And if you're feeling overwhelmed, you should. And this is just the tiniest tip of the iceberg.
But the great thing is they can hit pause, walk away, go get a refreshment, go outside, They may already be outside.
I'm actually thinking, well, yeah, we should work on that. I'm thinking at some point that we're about to go get a refreshment as well, I think.
We're about. So let's look at some additional resources and next steps.
And you're actually going to see this slide as we go through each of these modules. We like to give you next steps. We don't want to give you this information and then just leave you sitting there like, well, now what do I do? Well, step one, obviously next step, go get a new job if you want to. Hey, I learned some networking essentials. Let's go get a job.
Hey, not saying your current job is bad.
Exactly.
We're not labeling. No labels here.
But if you want to do something new and fun, this is a good start. So from a Microsoft standpoint, we offer some books. In this case, we have a specific study guide for this exam, the 98366 MTA Networking Fundamentals. It's a Microsoft official academic course. You can buy that book just about anywhere. Instructor-led courses, this one's a little more complicated. I put 4 of them on here because once you've done the networking MVA course, you may want more depth, you may want more breadth, you may want more information, you may even want some hands-on. You may want to go into a room and play with cabling and play with network cards and connect some computers together. We offer courses, instructor-led, in-class courses for this course, for the other courses that were the prerequisites, operating system fundamentals and server fundamentals. And then the last one on there is the actual exam. If you feel like after this course you want to go give that a shot, if you want to take an instructor-led course and then go give that a shot, Exam 98-366 is our Networking Fundamentals Microsoft Technology Associate exam. I think that's pretty much all we have for this module. So,
I think that's it.
yeah.
I mean, we've covered some really good stuff here. We've covered some really good basics. I would say personally, I think people are ready for more.
I think so. So we're going to let them get a drink and we're going to come back and give them some more.
Okay, we'll see you really soon.